There are quite a number of ways that you can control the RoArm-M2, and for this project we're going to use the web API, but you can use these other tools like MoveIt and Foxglove, which allow you to control the ARM in a more visual way. Obviously, we're getting the Python code and the machine learning models to control the ARM, so we're not going to need human interaction all that much. You can see here in the web API documentation, you essentially do a HTTPS GET and submit a JSON payload, and that tells the robot arm what to do. You can see here the reset command is pretty simple. You send it a payload with T with value 100, and that will reset it. From this API, we're not actually going to use a lot of these. We're going to do joint angle control and joint angle control in radians, as well as down here a Cartesian coordinate control, and at some point reset, and I think that's it. The majority of the functionality will be in the Python code, which translates complex commands into these simple get API calls. RoArm does supply a basic web application to sort of diagnose and test all of these web functionalities. The robot, once it's on your network or if you connect it directly via Wi-Fi, will give you this web application. You can see here, this is the default IP for this RoArm. You just go to that web address and it loads up this web application, and then you can actually start doing things with the robot. Okay, so let's initialize angle control. Let's move the arm to the left, move the arm to the right. So you just click these buttons on the web view and it moves. It's down, it's up. This is the angle for the elbow joint, down and up. And this is the claw. Open and close. Let's initialize that again. Let's move it a bit to the left. And then here you also have control of the LED. You can turn the LED on, the LED off. And then let's initialize coordinate control now. So here you essentially set your X, Y, and Z coordinates, and then the robot will move into those positions. The T is for the claw. You can see these are claw coordinates in radians, which is why the number is 3.14 at the beginning. Okay, let's initialize it again. And let's have a look at these examples in the web application. You can see down here, there's a lot of examples for all the different things you can set. Things we're really going to be interested in is movement control. So let's take this one, joint angle control, put that in. So when you click that, puts an example here in your input. And if you want, you can look at this documentation on the wiki, and it'll tell you what each setting does and how you should control the robot arm. Here, I'm just going to show you some basics. So you can just change this, and once you submit, you'll see the robot arm is going to try and get to those coordinates with the speed that is set here. You can see speed 10, which is about half speed. It's moving along. So let's reset it at maximum speed, which is actually 0 in this case. You can see that's significant speed increase. And let's change this. these letters, so the B and the S and the E, the H, these all represent the different joints. And it can get confusing because you'll notice here that it represents base, shoulder, elbow, and hand. But in other parts of the documentation, it actually changes. Let's have a look down here. Okay, so this is TBSE. So sometimes it'll be the initial letter, and sometimes it'll be the full word. So that's still initial letter. And down here, down here it's different. So down here it's the joint and has an ID. It's 1, 2, 3, or 4. So it does get a bit tricky sometimes because it's not very uniform. So here, for this API call, it's actually the full word. So it is a bit funky. You notice here, if I put in the wrong API call, it's not going to do anything. It's going to fail, which is not useful. So this tool is actually very useful when you're doing your debugging and trying to get your Python code right. You can just plunk in your instructions here and see what it does, or you can use this to create a series of coordinate movements and then program those in later, which is something that is being done on the Python code at the moment. Okay, so let's have a look at this code running on the Raspberry Pi that's controlling the robot arm. So if you look here on Visual Studio Code, if this is staged into a Raspberry Pi 5, which is attached onto the body of the arm. So this is the control unit for the arm. So this Raspberry Pi sends web requests to the robot arm to control it and do various things. You can see here in the project I've extracted all the robot arm functionality, plunked it into a class called robot, and this is the controller for the robot arm. The important thing to note here is when instantiating the robot class, you need to specify the speed and acceleration. Another important thing you need to specify is the IP address that the robot arm has. In this example code, you can see that I haven't specified it because I've just hard-coded it here for my purposes, but that's not ideal. In the init, you see you can supply the IP address, and then if it's dynamic, then your controller code can use that to set the IP address. Or if you've got multiple robot arms and you want to instantiate a few, then you can use that as well. Okay, so that's effectively the responsibility of this class. And you can see in here I've got a few internal variables that determine the orientation and assignment of the arms to different actions. The actions in here are used by the controller class here, which we can go through later, and that actually does complex motions on the arm sent by the controller software, which is hooked up to Telegram and various other things to make this robot arm seem autonomous. Now, a lot of this code is just taking instructions that are more understandable in English and translating them to the API calls that the robot needs to perform. Some of the stuff is doing conversions from radians to degrees, because some of the API calls are in degrees and some are in radians, and it can get a bit tricky. So here I'm just converting everything that's radian into degrees so that it's simpler to understand in terms of running and debugging. Now these initial functions, these just do translations from the English sort of description of the function into the API call. So you can see here exact move does the 121 call, here move to position, which is the coordinate command, that does the 122 command. So these are all just translations so that it's easy to understand what you're issuing to the robot arm. And then after that point, it's actions that move the robot arm in a way that's intuitive in English. So move left, the arm sort of moves left, move right, move up, move down, forward, backward, etc. So those are all basic movements that are easy to understand in English and translated to the API. Even the light, putting the light on and off, that's also wrapped. Grabbing with the claw, releasing with the claw, holding with the claw, that's also wrapped. Look around is an interesting one. So that's a command to get the robot arm to sort of probe around space so that the camera attached to the arm gets to see a lot of the space in front of it. Now if you go down here, these bits are the bits that you can extend and use and do whatever you want to do with it. This is kind of meant to be taken and reused and fit for your purpose. And here you can see I've got a do action function, which essentially takes commands from the controller, which comes from the model or Telegram or the AI bot, whichever one sends the message. It comes in here and then translates those commands into functions in the robot so that they can be actioned. So these are pretty one-to-one at the moment, but at some point they will do more advanced things. So here I've got in the main function just some test code to move the robot around, just make sure that these functions are working and so on. So I'm just going to run it, and you'll see that it creates instantiation of the robot object and then issues the look around command, and you'll see that the robot starts looking around. You can see here the robot is looking around very tentatively, set to speed 10, acceleration 10, which is considered to be medium settings on this arm. And once this is done, I can crank this up. So the interesting thing here is 20 is the top speed, but if you really want to get the max speed out, you set it to 0, which is kind of infinite. Okay, so let's have a go at this main function with the throw function instead of look around. It's not fully baked, so let's see what it does. Yep. So you can see based on that movement that it's intended to throw an object into space. I have tried it out a few times and it works reasonably well. I just need to get it to throw at particular coordinates. So that's effectively what this class does in a nutshell. It's not too advanced, not too complicated. You can take it, use it, and go forward with it. The code is essentially an extrapolation of the sample code that you get from the wiki. So it's based on that code, just with a lot of functionality added and a lot of translations added. So you can just take it and go ahead and make it do whatever you want it to do. So hopefully you have fun with that.